client and a server. The client sends a request to the server sends a response. And it's one closed transaction. So this is really the fundamental model. Did you notice I actually wrote réponse? This is the fundamental model that powers HTTP, that powers the web. And this is a great thing. This is what has allowed the web to expand the way that it has. But it's not the best solution for everything. There are some use cases where this model doesn't work very well, and where you run into some of the limitations. And I'm just going to run through the most common issues that can arise from this architecture. So the first problem is that it's unidirectional. You always have a client that needs to initiate a conversation. You can't send stuff at random from the server to the client. You always have a client who asks for data and a server who responds. And one way that you can think of this is kind of like Shrek. So you probably all know the annoying donkey in Shrek, right? So he's just so annoying. He's just going on and on because he wants to know if we're there yet. Are we there yet? Are we there yet? And this is kind of the same thing with how HTTP works, because he can't ask Shrek to just tell him when they're there, because you need to just have a response, right? So this is just kind of the polling thing that is quite annoying to do, so HTTP is not the best for that. Then we have latency issues. I mean, HTTP isn't that a heavy protocol, but there is some problems. For example, basically, each HTTP request is kind of a new connection. Now, this isn't entirely true, and there are some things, especially in HTTP 1.1, that kind of help you deal with this. For example, keep alive. So this will reuse the same underlying TCP connection for multiple HTTP requests. But there is still some latency issues with it. And then the third thing that I'd like to highlight is that it's stateless. So basically, every request needs to contain all of the information to identify that request or that user. So one example of this is cookies, right? You need to send the cookie data with every single request. And depending on how much that is, it can be quite expensive. Now, another thing, so this stateless model, this is really great for most things, because it means that you don't have a session. Now, if we take a look at this protocol stack again, we take a look at these layers, TCP has a session. So it's not like it doesn't exist. It's just that HTTP hides it from you and doesn't expose it to you. So what if we could use the underlying session and expose that? So let's take a look at the second part, the sockets. A socket is basically just a persistent connection between two machines for sending and receiving data. The term, I guess it originally comes from the C socket API, which is used for networking. And what the WebSocket protocols and the WebSocket specification then do is try to take these two things and bring them together. So it's giving you a persistent connection on the web. So many people don't quite get this, but WebSockets is really split up into two different parts. So there's two entirely different specifications. The protocol and the API. So let's take a look at the protocol first. The WebSocket protocol specifies how a browser or any other WebSocket client can interact with the server. So it specifies what data format is used in this connection. It's a persistent connection, and it defines quite a lot of things. I think the most interesting part is the handshake. So the WebSocket connection actually starts out as an HTTP request. So you have the client, it sends an HTTP request and requests an upgrade. In the headers, just use an upgrade header. And then if the server wants to upgrade the connection and agrees with this request, then it can send some response headers, but the connection stays open. So after the headers have been exchanged, it just reuses that connection, and it then becomes a upgraded WebSocket connection where either party can send data at any time. There's also, this is an important distinction to make. So many people say that WebSockets is like TCP for the web. There is one major difference. The WebSocket protocol defines message framing. So TCP is stream-oriented, WebSockets is message-oriented. With TCP, you just have some infinite stream of data that can just go in and out at any time, and it is your responsibility to pass that into individual messages. With the WebSockets, you don't need that because it already gives you the individual messages. It already does that for you, which is quite nice. So in order to support proxies, the guys who wrote this stuff, they really tested against a lot of existing software to make it possible to deploy this stuff and actually use it with existing hardware and software. So it uses some crazy hacks in the way that it formats the data just in order to play nice. And there are some issues. There are some proxies that reject this connection. I mean, they either just kill the connection after 30 seconds or something. The only way to get a reliable connection that will work in pretty much any case is to use SSL, because then the proxies are not going to touch it. They're not even going to see it. So since December of last year, this protocol is an RFC. And in fact, it hasn't, as far as I know, it hasn't changed ever since. So it is now fairly stable. The whole thing was started, I think, I only remember when I got started with it, which was 2 or 3 years ago. And back then it was really, really, really unstable. So you would just have random breaks. You would upgrade Chrome. That was my first experience with WebSockets. It was so painful. I would upgrade Chrome, and everything would just be broken. And I had no clue what was going on. So yeah, you had to go in, fix your server, find out what the changes were between the different protocol versions. Because of course, Chrome didn't think about warning you. They did publish a blog post, but you guys read the changelog of your browser every time you upgrade, right? Yeah. Okay, so let's take a look at the second part, the API. Now, the API defines the client-side interface. So this defines how you interact with WebSocket server from your JavaScript code. So this is just really basic Hello World example. Has pretty much all that you need to know right there. And this is really easy. So you just bind to certain events. We're going to take a look at that in just a second. And you can also use the send method on the WebSocket connection to just send data. Pretty easy. Oh, yeah, I don't have the slide with all of the different types. So there's on open, on message, on close, and on error. I didn't add the on close and on error because connections never die and errors never happen. But this is really all you need to know, right? So use cases is kind of an interesting thing. It's not just for WebSockets specifically, but it's also, and I don't want to bash those guys too much because I really like them, but this is also something that Node.js kind of has a problem with. Because, I mean, what are you going to use it for? And this is a company called Pusher. So they have like some managed WebSocket solution. So I was talking to one of those guys, and I wanted to do a demo for this talk. So I asked him, what should I do? What kind of demo should I do? And he couldn't give me a good answer because not even that guy could know what the use case is. But I think there are some pretty nice use cases. The one that is probably, that I've hardly ever heard mentioned from people, but I think has the most potential, is games. I think that is just really cool to have that kind of stuff in the browser and just accessible instantly. And then just stuff like notifications, for example, Facebook or Stack Overflow. On Stack Overflow, I don't think they're using WebSockets at this point, but they have this thing where when you're writing an answer to a question and someone else writes an answer before you, then you get a notification telling you that you've lost, basically. And then also collaboration, I think, could be really nice in the future. Do any of you remember Google Wave? Yeah, that is like old these days, right? But for that kind of stuff, it can be quite useful as well. And of course, chat, because everyone creates chat applications every day, right? It's a lame example, but I just included it for completeness. So let's talk about browsers. Now, as you can see, browser support for this is not too good, and IE10 isn't even released yet, so we're going to see how that goes. I think Opera finally did release. So in all of the real browsers, we do have WebSockets, at least in the latest versions. But it's kind of shit, isn't it? So what can we use to fix that? Has anyone heard of SocketIO? Okay, quite a few people. So SocketIO, what SocketIO does is, in my opinion, too many things. So one of the things it tries to do is it gives you a transport abstraction. There's some really fucked up ways that you can implement this kind of functionality for all the browsers. And maybe I can go into more detail on those in just a bit later. So this allows you to use WebSockets everywhere. Now, the problem that I have with SocketIO is that they're not just doing that, but they're also adding a whole ton of lots of different features on top. So you have broadcasting, reconnection, serialization, tons of stuff, and they don't use the same interface as WebSockets. They don't use the WebSocket API. So this is basically a monolithic solution, and it means that you can't use it with other things that depend on the WebSocket API. So what can we do to fix this? Sock.js. Who has heard of Sock.js? Nobody? Amazing. One guy. You're awesome. So Sock.js kind of does half of what SocketIO does. So they just focus on the transport layer, and they're not trying to invent their own API on top of WebSockets. They're just reusing the existing interfaces. So you can think of it as a WebSocket polyfill, if you want. So let's take a look. If you want to use Sock.js, instead of creating a new WebSocket object, you just create a new Sock.js object. And that is really all there is to it. There's one more difference as well. So instead of having the WS in the scheme, I don't have it here, but it's like WS://. So you need to have HTTP there instead. Actually, I'm not sure if you do have to, but all of the examples have it, so I guess that is the case. Now, let's talk about software stacks and all of the different parts that they have. So if you want to have this kind of functionality, if you want to have a server that is able to have long-running concurrent connections, these days it's probably the best idea to use some kind of asynchronous stack, because you don't want to do what Apache does or even PHP FPM to have lots of threads, so one thread per new connection, because then if you have 200 connections and those connections don't close, then you're just killing your machine. So an async stack basically uses asynchronous input-output with one single thread, and it handles, well, kind of one single thread, and it's able to handle that a lot better. You all know what Node is, right? Yes? No? Who doesn't know what Node.js is? Good. Just checking. You're not asleep, are you? So the nice thing about Sock.js is that it really integrates nicely. So this is kind of the server part of things. So the nice thing, not only on the client, but also on the server, is that it integrates quite nicely with existing parts. So instead of having just a WebSocket server or just a Sock.js server, you can actually integrate this with things like Connect and Express. Actually, you can't do it yet, but they're trying to fix that. And this allows you to do things like routing, so you can have prefixes and then only have that server under that prefix and that kind of stuff. So it just uses these existing parts. And you don't have to use Node. I mean, you can use Python for this. You can use Ruby. You can even use Java. Java is probably the best solution for this if you really need to scale. So why no PHP? Why wouldn't I use PHP for this? Awesome slide, right? Well, the way PHP works is that it's really meant to be run behind a web server, some existing web server, and most of those are going to have some model where they just spawn a new thread for each PHP request. The other thing is that the way PHP is architected is that you get a request, you do some stuff, and then it just dies. The process just goes away. And it's really optimized for this use case. So that's probably why PHP is not the best solution to have some kind of WebSockets. It is possible to do this. Actually, WebSockets, I'm not sure, but just long-running connections, it is possible to have long-running HTTP connections with PHP behind Apache, but it's not fun. I mean, it can't handle very much load. It's gonna die pretty fast. So what do you use to build actual applications, actual websites and shit? A synchronous stack, right? So in this case, I guess we have Symphony and an application based on that. And if you're really cool, you use Nginx. And so you have this async stack and the sync stack. So how does that work? So you really have two separate stacks. That would be my recommended way of doing it. So you have the synchronous stack that does the actual work. And then you have an async stack for doing this special kind of stuff. So you have your Nginx Symphony application, Silex. Silex is cool. And next to it, you have a separate server that handles all of this real-time stuff. And that's cool. I mean, I don't mind having two servers. That's all right. But how do they talk to each other? The answer is 0MQ. Who in this room has heard of 0MQ? OK, a few people. So what is 0MQ? Who in this room has used a message queue? A few more people. Now, traditionally, message queues are just systems that are used for connecting different processes. So you have some queue, you have one process, you have a second process. How do these processes talk to each other? You send something into the queue, the second process then reads from the queue. So this also allows you to do things like logging, routing, all kinds of stuff. Now, 0MQ is a bit different to most of those systems because it's not really a daemon. With most messaging queues, you have some kind of process that handles that stuff. With 0MQ is more like a networking library. So it's a library. So you have the two processes, and they just talk to each other directly without having any intermediary. Now, if you want to use 0MQ with PHP, you're going to have to install it as a PHP extension. But it's not too hard, and it works quite well. Actually, it works really well. So the way we communicate between these processes is we have PHP. So we want to send messages to Node.js. For example, if we have some kind of logging, and we want to display those logs in real time, we can just generate the log in PHP. So whenever the request comes in, we want to log that. So we send that through 0MQ into Node.js, and then Node.js is going to send it back to the client. So you kind of have this triangle thing, just to make sure you guys get it, because it's kind of hard to explain. So PHP, Node.js, the client connects to PHP, connects to Node.js. This is just one request. This request stays open. So whenever a request goes in here, you get the option to send something here, which then sends the stuff down here. All right. I think that should be clear enough. And just to make the point clear, this doesn't have to be 0MQ. This can be any message queue. And in fact, it doesn't even have to be PHP or Node.js. So just any architecture where you have a synchronous stack and an async stack, which is in most cases the only same thing to do, is going to need to have some communication between those stacks. So demo time, yeah! Let's hope this works. Can you see it all right? All right, all good. So the first example I want to show you, I'm just going to show you. So I'm starting the server with Node, and then I'm going to create a new tab. Then I'm going to open my browser. So let's see. Yeah, that looks better. So now what I'm going to do is send a message to the browser from my console. So I can do PHP publish.php, and then I can send any message. What message do you want? Hello world? Boring. So, did you see that? Oh, was too fast again? Boom. So this is quite nice. So let's take a look at how this actually works. Code. More code. All right, so this is the broadcast example. Now, let's take a look at the client first. So this is the PHP script for publishing. And yeah, it's only 14 lines. So this is using the 0MQ extension I was telling you about. So it just creates a new connection and creates a pub socket. So this is a socket for publishing messages. And then it connects to some 0MQ service that is listening, or maybe isn't listening, and then it just sends it. So pretty easy. So let's take a look at the server. Now, we have a number of libraries that we're using here. So the first one is connect. I'm just using that to serve the static files. So I will show you, but it's just serving the HTML and JavaScript. And then we have 0MQ. So this is just the inverse of the thing you saw before. So we're creating a socket, we're subscribing to everything. So with PubSub, you can subscribe only to specific channels, and it just does prefix matching. In this case, we're subscribing to all messages, and we're binding, and then the messages will come in. And whenever they come in, we're going to broadcast them using this broadcast object, which I will show you shortly. Now, one interesting thing that I'd like to mention here about 0MQ is that we have a publisher and a subscriber. Now, usually the publisher is binding. So usually you have some server that publishes messages. So binding means it provides the socket. And then you have a client that connects and then subscribes to events. Now, in this case, it's the other way around. So we have the client that is publishing messages and the server that is subscribing to messages. So this is a nice feature of 0MQ. All right, let's take a look at the broadcasting code. And I extracted this into a separate file in order to be able to test it, but it could also just be dumped right in here, and then it would be a mess. So that's why. Now, here we're requiring sock.js, and we're creating a sock.js server, and whenever a new connection is opened, we push the connection into this broadcast of clients. So broadcast of clients is just an array of connected users of connections. And whenever it closes, then we just remove that from the array. So then we have a send method. When you do broadcast.send, it will for each over all the clients and send a message. So for those of you who know SocketIO, this is almost the same. The words are a bit different, but in essence, you can just change 3 lines, and it's going to be the same thing. Now, what we then do in the server with this broadcast module, we need to actually install it onto a server. So this is, because of the way that sock.js works, it is really explicit about separating things. So you need to do some additional work in order to connect those, which does make it a bit more unusable, but I think it's not too bad. I mean, come on, it's like 5 more lines. So then we have the client code. So index.html just includes the sock.js client library and the client application. So if we look at that, it's really just the same thing that I showed you as the hello world. So it's just logging out all the messages. Pretty easy, right? All right, so let's take a look at some more demos. So canvas. I like this one. So again, I'm going to start the server. And this one is using SocketIO because I was too lazy to port it. So if we reload this, so now we have two windows. And whenever I draw something on this canvas, you're going to see it on the other one. And this works over the internet. Not in this case, but it can. Damn, typing is hard. You like it? All right. I'm not going to show you the code of this because it's quite a lot. Boom. So this is what happens when you stop the server. It starts getting really angry. All right, next demo, chat. This one is lame, but I want to show you anyway. So start the server using sock.js. Awesome. And actually, I'm going to use a separate window for this one. All right. So we have user 1, John Doe. So now I need to use a different browser. Canary. So this is, damn, let's try again. Jane Doe. All right, so now you can just hopefully type stuff. Yeah, it's quite easy to do. Actually, I want to show you how this one works. So let's take a look. So instead of broadcast, the chat one. And it's actually doing some advanced stuff. So first, we just have the core application. So whenever a connection comes in, we just loop. Okay, just a sec. So we basically have a buffer of messages. So whenever a connection comes in, we send that buffer to the user. So that means that the previous 50 messages are going to be sent on connection, which is great because if you're bitching about someone and then he comes in, then he sees that you were bitching about it. So that's a pretty nice feature. And then whenever any data comes in, just broadcast that. So it's using the same broadcast library, which is nice because due to the fact that I decoupled that, I can just reuse it over and over again. So anytime I need to do broadcasting, which can be quite common, depending on what you want to do, I can just reuse that. So whenever a message comes in, we add the message to the buffer, we broadcast the message to all of the connected people because it's using the broadcasting, so we don't have to really care about how that's working. And then if the buffer is too big, then we just remove some messages. And this is actually quite important, because if you don't do that, you're just going to keep all of those messages in memory. It's going to fill up and up until your process crashes. And you don't want that to happen, because that's really the downside. Whenever something goes wrong, the whole process dies and all connected users die, and it's really, really sad. All right, next demo. So I have another one. The tunnel. I really like this one. So actually, I need to cheat real quick because I need to see how to actually use it. So I'm going to start the server. Looks good. So what this example is doing, basically, if you've ever looked at some Node.js tutorials, they show you how to do really useful things like chat servers in TCP. So you can just have raw TCP connections and broadcasting on that, basically. Now, what I tried to do here was combine the WebSocket chat demo to the, combine that with the TCP chat demo, so we're doing both at the same time. And this one is using SocketIO. Again, I was lazy, so I just used that. All right, so I'm gonna have to have a separate window here. So what I can do now is telnet into port 500, 5,000 even. So now I'm connected through telnet. You all used telnet before? Probably, maybe. So now I'm connected here. So let's connect another one just for the fun of it. So telnet 5,000. Connection refused. Well, it's just IP6. All right, so now we have these two connected. So now I can just type stuff. So we see it here. We don't see it here, but we see it here. So what it's doing is it creates a TCP server, listens for data to come in. I can't talk. It listens for data to come in through the TCP connection, and then just broadcasts that to the WebSocket. So it's kind of this tunneling thing. So you could do some interesting stuff. Yeah, how do you, there we go. So if you don't like telnet, you can also use netcat. And then it's just going to connect, send stuff, disconnect. All right. And in fact, I even have another demo for you. I like demos. It's amazing. They actually all worked so far. So, yeah, boom. So the final demo I have for you now is, I just wanted to have some example of how to integrate this with Symphony. So you all know Packagist. So this is just my local setup of Packagist. And what I did was I take the Symfony 2 logging, which uses Monolog, and I just dump all of those logs to a WebSocket connection, so then you can display the logs in real time. And this is actually reusing the broadcast server, which is also kind of cool because this server is pretty generic. It just takes stuff through 0MQ and broadcasts it. So I can use it for one example, but I can also use it for something else. So, not server. There we go. So now, this is the page. So now I can create a new window, and as you can see, it's just dumping all of those logs out there. I don't know if it's useful, but it's pretty cool. And you can also use the app. Oh, no, other place. There we go. So you can also use the app controller, and then it's not going to give you all of the debug messages. And I'd just like to show you real quick how I did it. So I did this like half an hour ago. There we go. So it's not that much code. It's just simple bundle. So we have a controller for this thing. So then, oh yeah, this doesn't look so good, does it? So then we have this controller that just renders a Twig template. So let's take a look at the Twig template. This is just including sock.js. It's creating a connection to the broadcast channel. And whenever a message comes in, it gets the logs container which is here, and just adds the data to it. Yeah, I didn't use jQuery. That is badass. So then, for the server-side part, I actually used a custom monologue handler. So a handler is just some class that does something with log messages. So it could be a stream handler, which just logs to a file. In this case, it's a 0MQ handler. And you can easily configure this. So it's taking a host. There's a method for, actually this shouldn't be public. Has a method for connecting the socket lazily, because you don't want to connect the socket when you're not actually doing any logging. And then whenever you write, you just connect to the socket and send data through it. Pretty basic. So then we have the service configuration. So we just define the class. I guess you've all seen this before. I don't like XML, by the way. So we just define the class name. We define the service. And then we pass this as an argument. So this is the host that you can set in the parameters file. So in there, we just say the host is this 0MQ connection string. And then it just connects to that. And you also need to add it to the monologue handlers. All right, pretty basic. And I will publish this code as well. It's not done yet, but I will do it like 5 minutes after my talk. OK, so that's all I've got for demos. Now, well, kind of. So I want to show you some tools that you can use to debug issues, to actually see what's going on under the hood and how the protocol works internally. You're not going to understand it, but because it's just binary data, but it can be quite useful to just see if messages are being sent at all. So yeah, the thing is, probably the best debugging tool ever is like printf, or since we're doing PHP var dump. Some people would probably like to kill me for saying that, but I use that all the time. It's just, in most cases, it's way faster than using a debugger. But that's just my opinion. So Chrome Inspector, in the Chrome Canary build, which is like the beta build of Chrome, there is a WebSocket inspector in the toolbar. So I'm actually going to have to, yeah, broadcast, that's good. So yeah, Chrome, have you ever noticed this? Chrome just caches stuff without asking you. This is so annoying. So this is the Chrome Canary build, by the way. So if we go in the network toolbar, we can reload the page, so then we see all of the connected, so we can see the connected WebSocket. So then here, we have just the general stuff, and then we have this WebSocket Frames thing. So any message that is sent or received, you can see that happening here. So if I, for example, so if I publish a message, then it doesn't update because I don't know what the fuck these guys were thinking, but when you click on this, so you just need to click on the thing again, and then it refreshes. Makes sense, right? So yeah, obviously beta, but can be quite useful. And as you can see, we have different types of frames. O is an open frame, H is a heartbeat, and A, not sure what the A stands for, but that's just for, I guess, ASCII, which it actually isn't. So I guess that's just for text frames. All right, so that's the inspector. So then another cool tool is WSSH, which has nothing to do with SSH. So WSSH is just kind of a debugging server and client for WebSockets. I need to figure out how this actually works. So let's see. All right, so yeah, I got it. So when you call WSSH and pass it a WebSocket URL, by the way, since it's using sock.js, you have this /WebSocket thing. And in that case, you get a raw WebSocket connection. So sock.js by default has all of these fallback transports. If you do /WebSocket, you get the raw WebSocket. So we can connect to that. So then it's just dumping random crap. And so if we connect, let's see. Actually, yeah, so if we send a message now, there you go. So it just shows you what it received, which can be useful. So then we have ngrep. Ngrep is cool. So ngrep is network grep. It's kind of like a usable version of Wireshark. So you can, I'm so lazy, I'm just copy pasting this stuff. All right, so you need to tell it the same things that you would tell Wireshark. So you need to tell it which interface to listen on. And yeah, I'm just going to show you. So as you can see, it's just, it's showing the HTTP requests. So here you can also see very nicely that it's doing the upgrade. And whenever you send something, so that was the heartbeat right there. So now you send something, and then it shows it there. And then finally, not really WebSocket related, but for 0MQ, there's ZMQC. So that's kind of like a netcat tool for 0MQ. So in this case, it's basically a replacement for the publish script. So it's, the W is for write, the C is for connect. So we're creating a writable socket. We're going to connect instead of binding. It's going to be of type publish. And that's what we want to connect to. So then it's connected, and we can just type stuff. And you can also pipe things into there if you want to. Which, yeah, for debugging, also useful. All right. So just a quick recap. You should use sock.js instead of SocketIO because it plays nicely with existing solutions. You should think about having non-monolithic solutions, but actually having things that that work in different software stacks. So as I showed you, not just having this thing for Node, but you can use it with Node, you can use it with Ruby, whatever. And I think there's quite a lot that we can learn from message queues, because they've already solved all of these messaging problems for us. Yeah. So just a few links. The WebSocket RFC, it's like 80 pages, you know, kind of bedside read. The WebSockets API and sock.js. Also, the code is available on GitHub. Take a picture. Too late. Credits. Oh, there's one more thing, right? Of course. It's big. So many of you probably already heard of this project. So as I told you, PHP is not really the best solution for doing this kind of stuff. Well, can you do it with PHP? Hell yeah. So React is a project I created 2 months ago, basically. So what this does is it gives you the features that Node.js has, that you can have asynchronous I/O. So you can do that with PHP. If you're interested in the project, just come and talk to me. And in fact, so yeah, the website Node PHP, obviously. And this is guy Chris Bowden. He created a WebSockets library in PHP. And he's actually basing it on top of React. So this means that in the future, we will be able to do all that fancy stuff that the Node guys do in PHP. All right, that's all I've got. Any questions? Now? All right, thank you. Well, if you actually make it work with React, I'd be glad to mention.